Good morning. My name is Manikant. Now I'm going to say about the relationship between the minimum area ratio and the external reserve ratio for the subsonic inlets. It is related to the course of aerospace propulsions. So, as just now I said, it's a relationship between the minimum area ratio and the deceleration ratio. I will be relating in a sequence, that is finding the relationship between the thrust and the minimum area ratio, and thereafter finding the relationship between the thrust and deceleration ratio and eliminating the thrust from those both, and then forming a relationship between this minimum area ratio and the deceleration ratio. So let us go on. The thrust on inlet surface. So the net moment flux out of a control volume, if we go to an inlet surface, that is m dot as ua plus ui square ai minus ua square a max. Net moment flux is rho ai times ui square minus ui ua. Bernoulli's loss. Pi minus Pa is equal to rho times ua square minus ui square by 2. Now I'm going to mention what are those variables. Ua, ui, they are the velocities. That is, ua is a free stream velocity and ui is a inlet velocity. Ai is a inlet area and A max is a maximum area of the control volume. In the engine. Coming to the Bernoulli's, Pi and Pa are the pressures. That is, Pi is the inlet pressure and Pa is the extreme out of the inlet. Out of the bond, out of the consideration of the inlet, there is Pa, the free stream pressure, and rho is density, as we all know. And this is the basic things, and m dot is the deviation of the velocity, or the particles, the deviation of air. Can I say it properly? So the relationship between the thrust and external deceleration is given in this format. That is delta tau I by half rho ua square ai is equal to 1 minus ui by ua whole square. So this is the relation between the external deceleration towards the thrust. So we can say that we can say it as upon decreasing this ui ua, it becomes smaller, then the larger will be the thrust. So thrust will be greater if ui by ua is small. Let us consider the coefficient of pressure. Coefficient of pressure in terms of u max, that is Cp is equal to Pa minus P minimum by half rho a u square max. On the outer surface of nacelle, the pressure must rise from some minimum value Cp to the ambient value Pa associated with a straight parallel flow downstream, neglecting boundary layer. Upon neglecting the boundary layer, the Cp, from the minimum value, it must rise frequently, subsequently. And Cp must not be too large, otherwise the boundary layer will separate. So if Cp is much larger, then the boundary layer will be greater and it will be separated from the boundary. An average pressure difference with a factor S, value of which lies between from 0 to 1, can be written as delta tau I is equal to S times the Pa minus P minimum times A max minus Ai. Therefore, thrust increment equation can be written as the following. From the previous equation, just I have shown you, from this equation and from this equation, we can write the following thing, that is this one. That is S times the Pa minus P minimum times A max minus Ai whole divided by half rho ua square ai is equal to 1 minus ui by ua whole square. And this is the final relation between the deceleration ratio and the area ratio. So this is the area ratio and this is the deceleration ratio, and the A max is equal to 1 plus 1 minus ui by ua whole square divided by SCP max times U max by UA whole square. This is the relationship between the area ratio and the external deceleration ratio. So external deceleration ratio is from the relation of area ratio and the external deceleration ratio. It is clear that the larger the external deceleration ratio, the larger must be the size of the nacelle. If one is prevent to drag excessive drag, this one is actually to prevent the excessive drag. Even in the absence of boundary layer separation, the larger the nacelle, the larger the aerodynamic drag on it. So we'll be saying that nacelle level is small. So if external deceleration is moderate, its effect on nacelle size is quite small. This is a graph allocated with the minimum area ratio and deceleration ratio. So for a constant CP, I mean the coefficient of pressure. So 0.6, 0.5, and 0.4. Thank you. Thank you so much.